Imagine a developer using electronics hardware platform kits and boards such as Arduino, PIC, Raspberry Pi. They have to face some common issues like cross-platform support, lacking fundamental knowledge, powering issues, wiring problems, repeatability, sensor integration, and many more. For instance, when beginners are making circuits, they might provide incorrect voltages to components, which might lead to sensitive electronics being damaged. Typically, when an electronics enthusiast wants to make a new project, we start with a prototype using a breadboard with relevant microcontrollers, sensors, components, and we have to test it. Sometimes we have to even rearrange the entire circuit, or we need to make another prototype. That means we have to repeat the same procedure again and again. Also, there can be loose connections in the wiring. These kind of issues bring a lot of hassle and waste to the developers in terms of money and time. We understood this common pain point and designed 3 educational technology products. Let's talk about one of that, Quadrant. Welcome to the story of Quadrant. As the name suggests, Quadrant is about 4 platforms, namely Arduino, Node MCU, Raspberry Pi, PIC microcontroller boards. These can be connected individually or together. And these are the commonly used products by electronics hobbyists, enthusiasts, and also by serious developers. Let's turn around to the bottom side. If we need to use common Arduino boards, we can use this area. Here we can connect Arduino Nano boards. If we need to use Uno boards, we can plug it here. Or else, Mega board can be plugged in. This area is allocated for the Node MCU board. Nearby, there is an IC base to connect PIC microcontrollers. We can use a 40-pin and 18-pin PIC microcontroller with this. Now, if you are a Raspberry Pi user, you can use 40-pin IDE ribbon cable to connect Raspberry Pi board to Quadrant. After connecting the relevant board or microcontroller, if we look at it from the front panel, all board's GPIOs are extended to the top side connectors like this. If we need to access an Arduino board, here you can see Arduino Nano, Uno, Mega, Leonardo, Duo boards GPIO pins. Right next, we can see Raspberry Pi extended port. All pins are perfectly mentioned in the top side. Thus, we don't need to check the data sheets. Near that port is for PIC microcontrollers. All are marked very well to save users time without going to the data sheets. Here you can see Node MCU ports. Normally in Node MCU boards, pins are marked as D0, D1, etc. But here you can see both naming methods, including GPIO pin number method and board number. Now let's go to the component list in Quadrant. Here's a 7-segment display, a relay, and here you find liquid crystal display, a matrix LED display, DHT11 temperature and humidity sensor. You can find here a L293 motor driver IC. You can connect 2 DC motors. Here you find proximity sensors, active buzzer, potentiometer, LDR, IR, 8 LEDs and 5 internally pulled up push buttons. Also there is a 2-bit logic converter and 2 NOT gates. And these pins are allocated for inbuilt ATtiny13A microcontroller. These pins are allocated for max 7213 matrix extended pins. EEPROM DS1307 real-time clock with battery, ESP01 Wi-Fi module, Bluetooth module, MPU 6050 accelerometer gyroscope module. This is for controlling LCD contrast. Here you find all I2C addresses are mentioned properly so that without scanning addresses we can code them easily. and this is FTDI chip to make serial communications. Now again, if we look from the front side, we can see all sensor data pins are connected to the yellow connector. First, you can see the relevant data pin for the 7-segment display, ultrasonic data pins, LCD controller pins, relay buzzer, potentiometer, etc. Likewise, all sensor pins are mapped to the connector. More importantly, all sensors are already powered too. Now, let's see the functions in an example. We are going to use the ultrasonic sensor, Arduino Nano, to measure the distance and display the value in the LCD. So first, I'll connect an Arduino board with the computer. After that, I need to make a connection with the Nano board GPIOs and sensor pins. And I'm going to connect the ultrasonic trigger and echo pins to Arduino 2 and 3 GPIO pins. Next, I'll connect the buzzer pin to 13. And then I'll connect my LCD using I2C protocol. Finally, I'm connecting A4 and A5 to SCL and SDA pins. After connecting all, so easy. The connections are done, and let's start programming. Ta-da! Now you can see very easily that we have constructed the idea easily. Furthermore, if you need any other sensors, you can use the full breadboard. You can get power from power rails. Interesting thing is you don't need to provide power for the inbuilt sensors because all the sensors are already powered. If we plug an Arduino board, Quadrant will power up the board. For any case, users need more power, they can use external USB port DC jack. If someone wants to do an integrated project using multiple platforms like Arduino, NodeMCU, PIC and Raspberry Pi together, Quadrant allows to do that option as well. This is extremely useful for school students, engineering, university students, tech experts, researchers, developers, lecturers, instructors, IT teachers, beginners and enthusiasts, because they can quickly learn by coding and testing the code without having more hardware knowledge. Experts can make prototypes so quickly and save a lot of time. And also teachers can teach electronics coding very effectively to students. So there are many advantages by using Quadrant. If you go to the innovator.lk website, users can simply download all resources and learning material for free. There are multiple examples projects on the website. Quadrant is IP protected. We guarantee 100% that there's no product like Quadrant. And Quadrant allows makers to do quick prototyping in embedded systems quickly and efficiently. Beginners to experts can learn robotics, IoT, electronics in a couple of minutes without any hesitation. When beginners do innovations, there can be many mistakes that can happen accidentally. Thus, they are afraid to innovate using hardware. Also in academics, practical time is very crucial. Many accidents can occur, and it will take longer for all sensor peripherals to properly integrate. So students have less time to learn real concept. But with Quadrant, solve all those problems. And since we are a design-oriented startup, many more innovative solutions are coming soon, including open source projects. PCBs are designed by the Innovator team, manufactured in China. Products assembled by TOS Lanka, a BOA company, by maintaining high quality. We maintain export-level high-tech production quality by Innovator Park. The pilot run is done and successful. Now we are getting very good comments and very good customer testimonials. And now we are ready for the next bulk manufacturing. Now you don't have to worry about multiple microcontrollers, multiple boards, and multiple sensors. You have just one platform, which is Quadrant, and your problems will be solved. And you can now work on your real problems easily. So let's get started with Quadrant.